let's do this example. Okay, I'm going to use a calculator so you can understand what I'm doing. Okay, so using the Kramer's rule, the first thing that you're going to do is find the determinant. Okay, the determinant using the x, the y, and the z's. Okay, so you have 1, 3, 2, 2, 5, 6, 1, 1, 7. Okay, if you want to find this determinant, what I would do is I would go to your calculator. Okay, so I would go to menu, matrix vector, then I would go to determinant. Once it's blinking there, you go to matrix and vector again, create your matrix. Okay, it should be a 3 by 3. Why 3 by 3? Because you have 3 rows and 3 columns. Okay, so you just complete 1, 3, 2, 6, 5, 2, 1, 1, 7, and then you find the determinant, which is -1. Okay, so you record this. Since this is -1 and it's different than 0, we can use Kramer's rule, okay, to find the solution of this system of equations. Okay, so after that, what are you going to do? You are going to find your d sub x. Okay, remember, when you have the d sub x here, what you are going to replace, you are going to replace all the x's with the constants, meaning you're going to have 1, 3, 1, and then the rest of the original matrix, which is this one, is going to stay the same. So you have this equation. Okay, so you go again to your calculator, and I'm going to teach you how to be efficient. Okay, that one should be blinking, copy that one, and now I'm going to change my x column. I know that that one should be 1, the other one should be 3, and that one should be 1. Okay, so I find the determinant. As you can see, this is the matrix that I have over here. I hit enter, and I have that that's 2. Okay, so I record that one. Now, moving on, I'm going to do d sub y. So it's going to be exactly the same as this one. The only thing, you're going to interchange 2, 5, 6 by 1, 3, 1. Okay, so you have all this. Okay, so this is going to be your determinant. Okay, so I would copy this one. Okay, and then I would exchange the middle, which is going to be 1, 3, 1. Okay, so you have that it's -2, that determinant. Okay, and last but not least, you're going to find d sub z. Okay, why z? Because you have 3 variables, right? And the third one is z. Okay, so now I'm going to get the original, and I'm just going to interchange the last column by 1, 3, 1. Okay, so you have this equation. Okay, now you're going to copy, remember, the very first one. Okay, and you're going to change the last column. Well, if I can do it, that would be nice. 1, this is going to be 3, and then you find the determinant, which is going to be 1. Now you might tell me, so why do I care about this? Well, basically we are going to be almost done with this. Why? Because you know that your x is going to be equal to the d sub x divided by the d, which is -1. So you know that this is going to be your x, which you know that it's -2. The y is going to be -2 divided by -1, which you know that it's +2. And last but not least, the z is going to be 1 divided by -1, which you know that it's -1, and that's going to be the solution. Okay, so the solution, you can say that the solution is -2 to -1, and that's it. Okay, are we okay with that? So moving on, you have a theorem that tells you that the value of the determinant changes sign if any 2 rows or any 2 columns are interchanged. Okay, so in this example, you have that the determinant here is going to be 2 minus 12, which is going to be -10. Do you agree with that? So if you want to demonstrate that this theorem is true, what I'm going to do, pretty simple, I'm going to interchange row 1 and row 2, okay? So if you find the determinant of this equation, which is for -1, -2, 3, what happens? Well, you know that it's going to be 12, okay? And this one is going to be, what's going to be that one? -2, which is going to be +10, okay? So basically the value of the determinant changes sign. It's completely true because you know that this one was -10 and this one is +10. Okay, so you have that. Now we have another theorem. If all entries in a row or any column equals 0, the value of the determinant is 0. Well, it makes sense because we're going to multiply times a bunch of zeros. If any two rows or any two columns of a determinant have corresponding entries that are equal, the value of the determinant is going to be 0. Okay, so let's analyze this example. In example number 4, which you have that, okay? So if we suppose that row 2 has the same as row 1, meaning you have 1, 2, 1. Okay, what happens when we find this determinant? Okay, let's do it with the calculator. We know that the determinant of, let's call it, I don't know, A, of A is going to be equal to what? Okay, so again, you go to calculate, you go and, well, we can be efficient here. Well, menu, matrix vector, you are going to find the determinant, okay? After that, you are going to matrix, create matrix. You want a 3 by 3 matrix here, okay? And then you have that this is going to be 1, 1, 2, 6, 2, 2, 1, 1, 7, and you find your determinant, which is going to be 0, proving what you already know here, okay? So the next thing is, if any row of a determinant is multiplied by a non-zero number of k, then the value of the determinant is also changed by a factor of k. Okay, so in this example, what you had, it was -10. It's the same example as the previous page. Okay, so if we want to show that this theorem is true by finding the value of this, what happens? What would you do here? Well, don't overcomplicate this. You can plug this in the calculator or not, okay? You can do it by hand or not. Okay, so what are you going to do to find this? Well, if you want to plug it in the calculator, you go to determinants here, okay, as usual, okay? Then you put, well, let me put the parentheses there. I don't know what happened. So menu, matrix and vectors, you create your matrix, you know that you want a 2 by 2, so you're fine with that. And I don't know why my calculator is moving that. Okay, so we put -2 times k, okay, and as you can see, you can put variables, that's fine, okay, and then you have -1, and then you have 3 times k, and you have this equation, okay? So this determinant is giving you -10 times k, which is completely true. You know that this is 10 times k. You know that it was true. Why? Because this row number 1 was multiplied by k, that it's a number, right? So this is pretty cool, right? So remember, you can plug variables here in your determinant. The only thing you're going to have this symbol. It means that it's not exact. That's fine, okay? This is correct. So you can just prove it like that, okay? So that's for that, okay? So for the next one, we have this example, which is the same, that you're like, oh, boring. I know that it's -10. We need to demonstrate this theorem by multiplying row 2 by -2 and add it to row 1. This becomes your new row 1, okay? So we have this equation, then you have that this is -10, and this is going to be +5, okay? So this theorem tells you if the entries of any row or column of a determinant are multiplied by a non-zero number k, and the result is added to the corresponding entries of another row, the value of the determinant, it remains exactly the same. Okay, so what are you going to do? You're going to be like, okay, let's do it. Okay, so I know that this times this, or you can do it by hand or with the calculator. You know that this times this is 10. Okay, this times this is going to be negative 20, and you know that this is going to be negative 10, which is the original that you have. So this is true. Okay, I hope you're doing good, and bye.